Okay, this is a refresher also from Algebra 1. You learned how to find the slope of a line if you are given the graph. So we're going to do a few of these together. So I'm looking at problem number 1 on page 23. So you can turn there in your packet and do this one with me. So when we have a graph, we remember that we have a formula for slope. And when we have the graph, we actually really just care about this part right here of the formula, which says slope, or m, is equal to rise divided by run. So when I'm looking at the graph, which I am here, taking a look at this graph, I am going to first count. I'm going to start at a point, and I'm going to start right here at this point. And you can really pick any point, any of the points that are on the line, but I'm going to pick that point to start with, and I'm going to count how many I rise and how many I run to go from the point that I have marked here in red to this other point right there. So I'm going to count the rising first so I can see that I go up 1, and then I'm going to run over and count that, and that's 2. We just created what is sometimes called a slope triangle. So I'm rising 1 and I'm running 2, and they're both in the positive direction. Therefore, the slope of this line is 1 over 2, rising 1, running 2, or positive 1/2 is the slope. And looking at the line, I can check that, and I can see that this line does have a positive slope because as x is increasing, so is y, so that I can confirm that my slope is correct. I have the correct sign. It is positive. So next, I'm going to try another, and this one is problem number 5 on page 23. So again, I'm going to count my rise. I'm going to calculate the slope. So I'm counting the rise and the run. So if I'm going to start at this point and I'm going to end at this point, I'm rising none. I'm not going up at all. So my rise is 0 and my run is 1. And we know that we can have 0 in the numerator of a fraction. And when we have 0 in the numerator and we have another number besides 0 in the denominator, that just simplifies to 0. So the slope of this line is 0. If you recall, horizontal lines do have a slope of 0. So that is correct. Now, let's move on. Let's try number 8 on page 23. So you can see this is a vertical line. And again, we'll calculate the slope using rise over run. So I'm first going to start at this point and I'll end at this point. So counting the rise, this time I'm going down, looks like 1, 2. So my rise is -2 because I went down 2. And my run is 0 because I'm not traveling left or right at all. So I have a slope of -2 divided by 0. You learned in algebra that you cannot divide by 0 ever. So when I try to divide by 0, I end up with something that is what we call undefined. So the slope of this line is undefined. And you probably do recall that vertical lines have an undefined slope. You don't want to say no slope because no means 0, but it does have an undefined slope because we cannot divide by 0. Okay, now we're going to take a look at finding the slope if we have 2 points. So if I have 2 points, I'm going to find the slope. And I am still going to use my formula, but now I actually care more about this version of the slope formula, which says y2 minus y1 divided by x2 minus x1. So I'm going to take a look at problem number 1 on page 25. So first of all, by my coordinate points, I'm going to label the x's and the y's. So I'm going to label this x and y and x and y. And I actually don't really care about the 2 and the 1 subscripts too much. I'm just going to make sure that I go in the same order for both the numerator and the denominator. So my slope is y2 minus y1 over x2 minus x1. So that means I'm going to start here with my second point. So I'm going to use the y value of my second point, which is -15, and then the formula says subtract, and now I'm going to go to the y value of the first point, which is negative 16. And I'm going to divide that by x2. And now because I started with this point here as y2, I'm going to start with this point as x2 as well. So negative 7 is the value I have to use. And then it's minus. And then I'm going to subtract the x1 value, which would be positive 19. So I'm going to simplify that. I know subtracting a negative is the same thing as adding a positive. So I have positive 16 plus a negative 15, which is a positive 1. And I have negative 7 minus 19, which gives me negative 26. So I can just simplify that as I can put the negative out front, negative 1/26. So the slope of this line is negative 1/26. Let's try one more. So let's take a look at page 10. I'm sorry, problem 10 on page 26. So once again, we're finding the slope of the line through those two coordinate points. So I'm going to start by labeling xy and xy, my slope. I'm going to start with y2, which is in this case negative 18, and I'm subtracting y1, which is negative 18. And I'm dividing that by x2, negative 15, minus x1, positive 12. So I have negative 18 minus negative 18, which is plus positive. When I combine those, I do get 0. And negative 15 minus 12 gives me negative 27. So I have 0 divided by a number that is not 0, which means this simplifies to 0. So the slope is 0. So if you recall, we said a moment ago that lines that have a slope of 0 are horizontal lines. So if I were to plot these 2 points and connect them with a line through them, I would see that I'd have a horizontal line. The slope is 0. Okay, next we're going to take a look at finding the slope of a line when we're given the equation of the line. So take a look at page 27, problem number 1. So if you recall, you learned in Algebra 1, the slope-intercept form of a line is y equals mx plus b. And recall that the m is the slope, b is the y-intercept. We don't really need to know that for this particular problem, but we do need to know that the number in front of the x, when it's in slope-intercept form, is the slope. So when I look at number 1, I see y equals negative 5 halves x minus 5. That already is in slope-intercept form. So all I have to do to find the slope is identify the coefficient of the x, which is negative 5 halves, which means the slope is negative 5 halves. Taking a look now at number 7 on the same page. So this problem, when I'm looking at the equation, I can see that it is not in slope-intercept form, or y equals form. So I have to get it into slope-intercept form in order to identify the slope. So the first thing I need to do, I need to solve this equation for y, which means I need to get rid of the 8x. So I'm going to subtract 8x from both sides, which leaves me with 3y equals negative 8x minus 9. And I'm almost there. I want this to say y equals. It currently says 3y, which means I need to divide both sides by 3. So that gives me y equals negative 8/3 x. And then negative 9 divided by positive 3 gives me negative 3, or minus 3. Now I have the equation in slope-intercept form. So I can identify the slope by looking at the coefficient in front of the x. Therefore, m is negative 8/3. Number 13 on the next page, page 28. So this equation, y equals negative 1. Well, this one is in slope-intercept form. It's just missing the x. So you can think of it this way, y equals, there is no x. It's 0x minus 1, which means that the slope, or m, is 0. If we were to graph this, if you recall, if we were to graph this, we would have a horizontal line at negative 1. that would be y equals -1. That would be the line. And recall we said earlier that horizontal lines have a slope of 0. So the slope is 0.